We are now going to discuss the second case of five electron densities where I'm going to have one lone pair and I'm going to have four bonding pairs of electrons. So I'm still going to have five electron densities, but there would be one lone pair instead of a bond. So I know that five electron densities has this particular shape around it. There's going to be a fan shaped middle part where the angles would be 120 degrees and one bond on top and one at the bottom. So those bonds would be making an angle of 90 degrees. So the example that I'm going to take is the molecule of SF4. Now SF4 has one lone pair on S. S is the central atom. So what I'm going to do is I'm going to copy this molecule over here. So let's pick the shape and let's try to fit and figure out what SF4 is going to look like. So I'm going to rub off this X in the middle. That would be my sulfur atom, and there would be four fluorines bonded to this sulfur atom. So there are four bonding pairs of electrons. And now this bond over here, instead of having a bonding pair of electrons, I'm going to have lone pairs on this side. So I'm going to rub off this bond over here because this bond would be, there would be no atom attached on this side. Instead I'm going to have a lone pair of electron over here. The way I can figure out that I have one lone pair is because sulfur is in group 6. It has 6 outer shell electrons. So one is being shared over here, one over here, one over here, and one over here. So that's 4 electrons gone. So I'm left with 2 electrons. So that's one lone pair. So this is the shape of the molecule of SF4 when I'm going to have one lone pair and I'm going to have 4 bonding pairs of electrons. So this would be the geometry that the sulfur atom would have around it. Now the shape of this molecule is called a seesaw shape, and the reason why it's called a seesaw is because if I pick this molecule and I rotate it, so if I rotate it, so let's put it like this. So if I rotate it, then it resembles a seesaw, just like a seesaw. So the shape is called, it's called a seesaw shape. And the angles are going to be between the remember there was a fan shaped part in the original molecule. There were 3 bonds that were arranged in a triangle on a planar manner, like a fan. So these 3 bonds were arranged in a fan shaped manner, and there was one bond on top and one at the bottom, and the angles between these bonds was 120 degrees. So the angles between these bonds would be 120 degrees, whereas the angle that these bonds would be making, they would be 90 degrees, and the angle between these 2 fluorines over here, that's going to be 180 degrees. So what I'm going to do is I'm going to put an actual 3-dimensional model of this molecule in front of you so that the picture is more clearer. So these 2 bonds, they're acting like a stand, so the angles between them, that's 120 degrees. These bonds over here, they are making an angle of 180 degrees with each other, and the angles that these bonds are making with these 2 bonds over here, that's 90 degrees. So the angles over here is 90 degrees between these 2 bonds and between these 2 bonds. Those angles are 90 degrees. The angles between these bonds, that's 180 degrees, and the angles between these 2 bonds, that's 120 degrees, and it's going to be called a seesaw shape.